Yes, let's start.
Right. Hi everyone. Thank you for having me today. So I'll be talking about how we can build AI agents with the help of Gemini and LangChain. And the session is going to be more towards hands-on experience, like the workshop mode, where I'll be flipping towards some presentation slides and then to my code editor as well. Lots on. But before that, I'll introduce myself. I am Aditya. I'm working as a senior software engineer at Watt. I'm recently started working in the distributed system domain. I'm also a Google developer expert, and in my free time, I post technical videos on my YouTube channel, which is youtube.com/slash Aditya Joshi 12. Uh, yeah, so this is what pretty much about me. Now let's jump towards the agenda. What we are going to talk or discuss today. So we'll be talking about AI agents, why I chose or why you can choose LangChain or Gemini, and what we are going to build today. And then we'll have live demo and hands-on session. So some of the key learning objectives for the attendees would be that how they can set up their AI projects with the help of TypeScript, how they can connect Google Gemini with LangChain, how they can use LangChain for building up the agents, how they can build custom tools in their AI agents with the help of Zord library. And they'll be also going to learn about React AI agent. I'll talk more about what this React agent means and how they can integrate real-time APIs of different systems with their AI agents. And then we'll also talk about the conversational memory, like how they can persist the memory or persist the session so that anytime if they come back to the same session, the context is already there and the context is never lost during when they switch to the different sessions. So this is the overall objective, and attendees are going to get something out of uh, to this session. Now the tech stack, what we are going to use today is TypeScript along with Node.js. Then we are going to use LangChain as the core framework for building up our AI agent framework. Then we are going to use Google Gemini for the AI or LLM models. We are going to use Zord as a library for input validations for the tools that we are going to create for our AI agents. They are going to use Zord for the schema validations. We'll be talking about AI memory and how we can persist those memories with the help of database like SQLite. And then we are also going to use a weather API called weather.in. You can use any third-party systems or any third-party APIs with your tools as well. Now, some of the prerequisites when we before actually jump into the workshop part or going to the hands-on part, that there are certain prerequisites before you actually start implementing or building out the agents. You need to have Node.js installed, preferably version 20 plus. You need to have your Google AI key or the API key. You should have some fair understanding of the JavaScript or TypeScript, and you can use any code editor of your choice. For today, I'm going to use VS Code along with the terminal. Now, before actually jumping into the hands-on part, I just want to set up some ground that what we are going to do today, what these agents are, and what LangChain is essentially. Uh, so I've created a boilerplate code repository, and the boilerplate for the source code is already available in this repository. Feel free to scan the QR code and get to the repository, or you can just type out the link which is mentioned in the slide as well in order to reach out to the repository. Okay, so let's talk about what AI agents are. I think by now you must be having some fair understanding what AI agents are because throughout the day the sessions are towards AI agents, LLM, right? So AI agents are the agents which has the capability of LLMs, the low language or the large language models, plus the tools, and you can create your tools as well. You can use the tools that are offered by the SDKs as well, and they also have the reasoning capabilities as well. So this is what essentially an AI agent is. Basically, it helps you in doing your tasks as well. it's not just a conversational chatbot, right? So typically when OpenAI released the GPT, the chat GPT, it was essentially just a chatbot where you just type out your queries and you just get the response back in the form of text. But now AI agents are far more ahead of that. They can actually execute the task for you, even when you are not around. If you are sleeping or if you are not near to your machines, they can still execute things for you, right? And AI agents typically follow the React pattern. We talk about what this React pattern is. Basically, it's a pattern that allows the agents to reason, right? It's going to do the reasoning, it's going to take the action, and then it's going to observe the output, and again going to take the observation on the output and see whether the output is meeting the conditions or the criteria or not. So it's a continuous loop that's going until when the conditions are met or when the desired output is reached. And once we have the desired output, the results are shown back to the user. So essentially, the user is going to write out the query, and the query goes to your LLM model, your large language model. And if the LLM decides that it needs to make a tool call, or if it has that knowledge by by the LLM itself, if it decides to make a tool call, it's going to take the action, and then it's going to observe the response. Again, the response is fed back to the LLM, and it's going to take the decision whether the response is meeting the conditions or not, the response is actually good or not, right? And once it has that confidence, it's going to give you the spit out the results. So this is what the AI agents is in a nutshell, and we discussed about the React pattern as well. It's basically a continuous loop that continuously observe your output, and if there is a confidence on the output, then only the output is returned back to the user. Now let's talk about the LangChain. So LangChain is a framework which helps you in creating AI agents. Now there are a lot of different other frameworks as well. For example, Google has something called as Google ADK, Agent Development Kit. There is a LangChain as well. Then there is a Crew AI, AutoGen from Microsoft. So there are a lot of different frameworks that are available, and you can use any of them. But today we are going to use LangChain for building of the agent. And LangChain also provides you an orchestration layer, which means that your LangChain agents, the agents that you have built using LangChain, you can orchestrate them, and there can be a root agent which can orchestrate the task to the sub agents with the help of LangGraph, right? So I'll show you what LangChain, what LangGraph, or other products of the LangChain community are coming from. And LangChain can easily connect to the models, different LLM models. It can connect to Gemini, GPT models, Claude models. It can connect to various models. It can integrate with different tools. You can write your own tools as well. It can integrate with the memory systems. You can define your memory. For example, if you want to use SQLite or Postgres or any other database so that you can parses the memories there. You can define the workflows with the help of LangGraph, and it can also integrate with the retrieval system, basically the RAGs as well. Now, let's talk about the LangChain ecosystem. So there are different products or different tools available in the LangChain ecosystem. The first one is LangFlow. Now, this tool essentially helps you in prototyping or designing your AI agents. Basically, it's a low-code platform, low-code, no-code platform, where you just simply drag and drop and create the AI agents. And behind the scene, it also gives you the code for that AI agent that you have built with the help of dragging and dropping various components. Now, LangChain is it's a core framework, and this is typically you would be using as a developer for writing out the agents, because you don't want to just do the drag and drop and build out the agents. Rather, if you want to build the production grade agents, typically you want to write the code by yourself so that you have better control or better visibility what's going on behind the scene. The another framework or another layer is LangGraph. Now, LangGraph helps you in orchestration part. Basically, if you have different agents, LangGraph can decide that which agents to be called at a different scenarios, and it can route or collect the responses from different agents and then give to the main agents as well. So LangGraph is essentially used when you want to build multi agents, and you have a root agent which is kind of orchestrating the entire workflow. The another framework or another library is LangSmith. Now, LangSmith is typically used to enable observability in your AI agent. helps you in bring up the telemetry. It makes the debugging the AI agents a lot easier. So if you want to, if you're building your AI agent and if you want to integrate telemetry or observability to your AI agents, then you can definitely consider LangSmith for having that. But today we are just going to focus only on LangChain and a bit on the LangGraph as well, not on the LangFlow or the LangSmith. Now, let's talk about the workshop part, like how we are going to move ahead. So first, we'll be doing the project initialization. We are going to create an empty project. If you don't want to create an empty project, you can just always refer to the GitHub repository that I mentioned in the previous slide, or this is the link to that GitHub repository. Now, there are 2 folders in the GitHub repository. You just have, for today, you have to just follow the first one, which is AI agent LangChain. And this repository is this particular folder is what we are going to look or deal with today. So this is the boilerplate code, and all the packages and everything is already configured in the package.json. So you just have to do npm install, and all the packages will get installed for you, right? For me, on that, and it's here. I have already cloned that repository, and all the files is available on my local machine. So moving ahead, so if you want to start from scratch, you can create a folder with any name. You can just initialize your npm project. You can install the required dependencies, and you have to also initialize the TypeScript, because today we are going to use TypeScript for building of the AI agent. And how you can do it? You can simply create a folder. You can just run npm init-y. This is going to create the Node.js project for you, and then you can install the LangChain specific libraries and the Zord library for the validation in your project. Once you have done that, or you just need to create a few folders like the src folder or the index.ts, and one more file called env. This is the file where we are going to keep our Google API key. Now, for me, I have already done that. So if you see, there is the index.ts, and this is what I've cloned from the Git repository. So this has few of the boilerplate code already available, and there is this env file as well, which has my API key. So this is the API key. I'll just revoke the API key post the session because I don't want to share my API. But this is how you are going to keep your API key in your project with name Google_API_key. And how can you get the key? So you can simply go to AI Studio, and from here you can just go to the API section. There at the bottom you will see that there is a section called Get API Key. You can just go there, and from here on the top right you will see Create API Key, and you can just simply go ahead and create an API key from here, right? Once you have the API key, you are good to start for the workshop. So I'll move back to the presentation, and I'll just talk about tools, what tools are in the context of AI agent, and then probably we'll start the implementation part as well. So you can think of tool as the hands-on of the AI agent. This is the analogy that I'm trying to help you in understanding AI, the tool, the concept of the tool. So with the help of tools, you can accomplish any task. For example, if you want to make a call to the external system, if you want to fetch certain information from an external system, you can use something called as tools. You can create your own tools, and with the help of these tools, your AI model or your LLM can integrate or talk to those subsystems with the help of these tools. So tools are essentially going to help you in connecting with different systems. Now, there is another concept called MCP servers that you can also use. But for today's agenda, or for today's session, we are going to only focus on the tools part for interacting with different systems. So tools, with the help of tools, you basically call the functions. You are writing of the functions, and these functions are wrapped in something called as tools. And these functions or these tools that you are going to create, they need to be well structured in the terms of input. So the input that these functions are going to expect They need to be well structured, well defined, because your AI agent or your LLM doesn't know much about the function, right? So it's going to infer those properties or the parameters based on the schema that you have defined. So assume there is a simple function, for example, addition, right? And there are two parameters that function is expecting. If you have defined the proper schema for that, then your LLM model can, provide right set of values to that function. If you don't define the schema, then your AI LLM model is not going to provide the right set of values to the function, and the system or the function may not work as per the expectations. So how do you create a tool? You just write a function and you define certain set of validations and schemas toward that function. And in that function itself, you define the core logic, like what actually you are trying to do. And let's see how you can define or how you can create your own tool. So I'll go to the code repository here, and this repository particularly has two parts. So I split this particular workshop into two parts. The part one deals with building the basic agent, and the part two deals with building up the agent with memory, like with the persistent memory. So in the first part, we are going to see how we can build the basic agent. So I've already opened the instructions file here. There's a readme file, and I have already installed all these repositories, so this is I don't have to do any of these steps. But if you're doing this for the very first time, then feel free to run the steps. Otherwise, the dependencies might not be there, and you might run into issues when you run the project. Uh, and as the part of boilerplate code, this configuration already comes into the package.json file. So essentially, you have to define the type as module. And if I just try to open my package.json, you can see that I've defined the type as module. This is required if you're running a project. So I've done that. And the environment variable is also I've configured. So I've passed this environment key into my env file. You can see that key here. And once you have done all the steps, like the step number one, step number two, you are good to start creating your tools. So let's go ahead and create a very basic tool for now. And we are going to create a tool called square tool. Now, what this tool is going to do, you just pass a number to this function or to this tool, and it's going to return you the square of that number. For example, if you pass the number as 2, it's going to give you the square as 4, right? If you pass the number as 3, it's going to return you the square as 9. So this is a very basic tool that we are going to create. And then we are going to create one more tool, which is going to interact with an external system, right? So let's go ahead and create this tool. I'll just copy this portion here, and I'll just keep it here, and I'll just help you in understanding what this tool is doing. So here you can see that I have wrapped this function inside a function called tool, and this function is coming from the LangChain repository or from the LangChain library. And here you can see that I have defined the schema, right? And you can see that I've defined the name of the tool. The name of the tool is square. So whenever my LLM model reads or identifies this tool, it is going to refer it with this name, whatever name I've defined. And based on the description, it is going to decide which tool to call. For example, if you have, let's say, 10 such tools, and if you pass a prompt to your LLM, it has to figure out which tool to call. And it does that based on the description you have defined. So description needs to be very descriptive. If you just give a very unclear description, then it will have a difficult time to identify which tool to call. And then I've defined the schema, and it's basically an object. And inside that object, I want a number, and that number is basically the number for which I want to get the square, right? So the property, the number is going to be of type number. It should not be a string or a Boolean field, right? Or not a true false kind of a thing. So it has to be a number strictly. So this is the schema that I've defined. I've given the name to tool, description to my tool, and the schema. And with this, you are good, right? You have created a very basic tool. Now, once the tool is not itself sufficient to do anything, right? It needs to be called by someone. And in our case, it is going to be called by the agent, right? Because AI agent is going to call that tool. So let's go ahead and create the agent. So in order to create the agent, it's very simple, just 3 lines of code. And let me just copy this. And here you can see that I'm using this function called create agent, and this create agent is again coming from LangChain, in the LangChain library. And here I'm defining which AI model to use. And for this demonstration, I'm using a very minimal model, Gemini 2.5 Flash. It's a very lightweight model. This is what I'm going to use today. And here you can see that there is a field called tools, where you have to pass your tools, whatever tools you want to give to your AI agent. So in my case, I've defined this tool called Square Tool, right? This is the tool that we just created. And I want to create one more tool called Weather Tool. Let's go ahead and create the tool and explain what this tool is doing. So I'm going to add this tool. Now, this tool with name Weather Tool, this is going to call an external system. It's going to call an external API and get the weather of a specific city. Now, if you see here, I'm just making an external call to this particular endpoint, witter.in, and I'm passing the city name. And the city name is again coming as an input to this tool, right? And let's talk about the metadata for this tool. So the name of this tool that is going to be understood or recognized by the LLM is get weather, get underscore weather. So with this name, our AI agent is going to detect this tool. Then this is the description of that particular tool. So it says that get the real-time weather of a specific city. And then this is and in the schema, I'm defining that it has to be string, and I'm giving some description that what kind of property that particular can have. In this case, what kind of value particular field, which is city, can have, right? So this is how you can create a tool. Now you can see we have defined 2 tools. One is the square tool, which is a local tool, not doing anything fancy, just returning us the square of a number, just doing n into n. If you pass the number n, it returns n into n. And for the other tool, it is going to call external system or external API. It can be a database as well in your case. If you want to integrate with your database system or any third-party system, it can be that system as well. So you just, for now, for the demonstration, I'm just calling this third-party API, and I'm returning up the response, right? So very straightforward, very simple implementation. And when I'm creating up the AI agent, I'm passing both the tools. So far we are good. What we have done, we have defined 2 tools and we have created an agent, right? Now let's go ahead and start interacting with this AI agent, right? So how can we do it? We just have to simply call a function which is agent.invoke. And let me do this thing. Let me just copy this whole function. And let's understand this. So I've defined a function called main, and I'm calling this function, and everything is happening inside this function called main function. Now here I'm calling this AI agent 2 times. One is I'm asking about the square of a number, right? And the second time I'm asking what's the weather in Paris right now. So it's going to give me the real-time weather of that city, which is Paris in this case, right? So here you can see I'm just printing out some statements so that we have a clarity which tool is being called, and then I'm printing out the response from that AI agent, right? So let's go ahead and let's call this. And if you want to run this project, you just simply do npm start. This is going to run that project. Let's go ahead and run this. So if everything goes fine, this is going to call both the functions and give us the response. So here you can see it printed up the first statement, which is querying square tool. Here you can see this was the first statement. And then the second instruction here was to invoke the agent. And we defined the role as user, because this is what we as a user want to ask. And we ask what's the square of number 15. It gave us the square of number 15 is 225, which is correct. And we asked for what's the weather in Paris right now, and it gave us the weather is just 13 degrees Celsius, right? We can ask for, let me just change the query and let me ask the weather in a different city, for example, India. Now, if I just again run this, this is going to give me the current weather. No, it should not be India. I need to specify the city here. It clearly told me that you need to specify city. For example, let me specify city as Delhi. And it should go ahead and give me the response back. So here you can see in Delhi right now the temperature is plus 40. Let's do one thing. Let's see the picture of Ahlen. Okay, it says plus 13 and partially rainy, sunny. Hope this is correct. So yeah, this is how you kind of invoke or call your AI agent, right? So it's a very one line of instruction that we have called. You just call agent.invoke and you pass your message or your query, and your AI agent is to determine which tool to call. So in this case, we have two instructions. We invoked it twice. So first one was it was able to figure out that it has to call the tool square tool, and the second query it was able to figure out that it has to call the weather tool, right? So this is how we are able to build a very basic AI agent. And this is what we kind of discussed, the tool selection. Your AI agent is able to determine which tool to choose. It has to choose the square tool or the get weather tool. And you can see that we were calling this external API witter.in just to get the real time weather, right? So, and if you want to, so for now I was just calling this API, which doesn't require any API key. But if you are building any production system, just always go with the API with the production APIs. Like if, for example, you can always go for openweather.org and get their API keys and the APIs integrated. So this was the first part, the workshop. Hope you got some understanding of building the AI agents, how you can build tools, your custom tools, how you can integrate with them different system, and how you can actually invoke them. Now let's move to the slides. And now let's move to the next part of the workshop, which is memory and persistence. So let's do one thing. So before actually, moving towards this presentation, let's do one thing. I'll just change all of this. And let me just do one thing. I just want to show you one thing about the memory part, like how AI agent doesn't preserve your memory by default. You as a developer has to bake those mechanisms so that it kind of, maintain or preserve the memory. So let me say my name is Aditya, and I'm just going to ask him what's my name. So a very simple prompt is what I've given. I don't need the response of this one. Okay, so a very simple instruction has been passed to the AI agent. And what I'm trying to do here is I'm just telling the AI agent that my name is Aditya, and I'm asking it one more time, what's my name? Let's see what's the response looks like. So I'm running this AI agent again. So here you can see that in the same session itself, in the same process of the Node.js or the application that we are running, I just told it clearly that my name is Aditya. And when in the very next instruction I asked, what's my name? It is unable to figure out. It says, I don't have I don't know your name, even though I clearly specified that in the very first instruction, but it is still unable to, capture or hold those details. And this is why, or this is why it's important for us as a developer to preserve the memory or to have the persistence so that the instructions or the conversation that we are having, they are or they are being stored, or the context is always stored. So here you can clearly see that it is unable to figure out, even though in the very first instruction in the session is I'm just giving it details about my name. So let's go ahead and let's move to the next part, which is memory and persistent conversion. And now you understood that why we actually need the memory and the persistent in the conversation that we are having, right? And we can do it in two ways, right? Either we can have the in memory, which is the memory is not going to get stored somewhere, rather it will be kind of in memory, just like it will be stored into the RAM, or you can either store the memory or persist the memory in some, for example, in a DB or in a file. You can also do that, right? So we discussed about the problem statement just now itself, right? That AI agents are stateless. They have kind of a goldfish memory. They don't preserve anything. And the example is what we just saw, right? We just gave it a prompt that my name is Aditya, and the very next statement was what's my name, and it was unable to figure out, right? And that is why we need persistent, because we want to preserve the entire context, whatever conversions that we had, so that LLM can better give us the response based on the previous conversions that we had. And in order to have the memory, sorry, in order to have the memory, we need to implement something called as checkpointing. So after every certain conversion, there will be a checkpointer, and the previous conversion will be checkpointed, and they will be kind of a stored or retained somewhere, and they can be looked up anytime by your AI agents. So they also maintain the message histories as well. So all the conversations that you have done in the past, they will be maintained in the persistent memory. And you can always have in memory kind of a setup, or the persistent memory where the memory is actually persisted onto device or disk. So let's go ahead and let's actually see this in action. So I'll go to my code editor again. And now this is the second part of the workshop. This is slightly advanced, where we are dealing with the memory. So I'll just open this instructions file. And yes. Okay. So now let's go through the instructions first. What's the objective of this particular part, the second part of the workshop. So we are going to understand how the agent memory works. We are also going to implement a memory saver function. This function is coming from LangGraph library, and this helps in doing the checkpointing. And we also need to have something called as thread ID preserve. Basically, you can think of thread ID as a session ID, which helps you if you are having multiple sessions. Then all the chat or all the conversations are stored or marked against that particular thread ID that you have. So if you are having, let's say, 10 different sessions, so all the conversation will be captured against the thread ID. Now let's go ahead and see the implementation, how you have to actually implement. So we just need to implement this or import this library, this function, which is memory saver. This is coming from LangGraph. Let's see if I have this. So I have already imported this particular import statement. This particular function is already there. And now I can just create an instance of memory saver. And this is in memory kind of a persistent that we are going to have. It's not a persistent on the disk, rather the conversations or the chat will be persisted into the agent memory. And then in the agent that we have created, we have to just add one more property here, which is check pointer, and then we have to point it to our memory. That's it. So now, once we kind of do this, we define the checkpoint, and now the persistent is kind of enabled by default. Now, I remember I talked about thread ID. So for every conversion, I need to pass the thread ID, and that is what I'm going to do here. I'm just creating an object. Let me just do this, or let me just copy this entire section, this main function. I'll just replace the previous main function and add this here. So now let me just give it a meaningful name. So here now you can see that I have defined a new object called config, and this has a property called thread ID, and you can give any value to this particular variable. And for now, I've just given session 123. Now, whenever we are calling our agent, we have to pass this configuration in order for us to maintain that context or to maintain that memory. And so here you can see that I'm saying my name is Aditya, and in the next instruction, I'm just asking what's my name. Let's see if this runs properly. So here you can see that this time it worked differently, right? So if you remember, in the first, just before implementing these changes, we asked it the same question. I gave it my name, and then the second question that I had was, what's my name? And it was unable to figure out. But right now, if you see here, it is able to give me the response. It is able to give me my name back, right? Let me just run it again. And it's going to give me the same kind of a response. So here you can see, it says, I'm sorry, I don't have memory of past conversion. I only know that your name is Aditya because you just told me. So it has kind of a retained that context, right? That information is being stored somewhere. And for now, we just implemented the in-memory storage where the context or the conversion is being stored into in-memory. But later we are going to see how you can integrate or how you can store this entire memory into or the conversions into some database as well, right? So hope this gives a pretty much idea on the memory part as well, like how you can maintain the context. Now in the same instruction file, I have the persistent memory as well. In this case, the memory will be kind of persistent and will be stored onto the disks. And I'm going to use SQLite DB. It's a DB that's very kind of a lightweight. I already have it here. I'm just going to delete it, and this will get automatically created once I run my program. So once I run this application, it will get automatically created. By the way, let me just go ahead, and I just want to show one more thing. So in the instruction, there is a link for the memory part for the checkpointing. And here you can see, let me just switch to the JavaScript part. Okay, the docs are not updated. So here you can see that we just use the in-memory saver, but there are SQLite, there are Postgres or async Postgres saver, and you can write your own implementation as well. So you can just write your implementation of checkpointing as well. So that is also again possible. If you want to persist, or if you're using some other database, you can kind of do that, right? But by default, in the LangChain or in the LangGraph library, there are some built-in savers that are already there, and you can use any one of them, right? And for now, I'm just going to use SQLite just to show you that the memory will get persisted there, and you will see that there will be a database that will get created for the SQLite. So in my case, I have already installed this SQLite checkpointer library. If you don't have it, you can always go ahead and install it. I need to just import the statement. Let me see if I have the import here. So I already have the import, so I'm not going to just run this. And now I need to initialize my memory. So I'll just remove the previous one. and I'll initialize it. And I've given the database name as checkpoint.db. You can give any name, whatever you wish to, and rest of the things remain same, right? This is how exactly we define the checkpointing to our AI agent. No change in that because we already kind of did that. And now once you kind of run this, you will be able to see that a new DB will get created for us, right? So let me just run this. And here we will be able to see that a database will get created for us that's going to persist all the information that we have. So here you can see that I asked the same question. This is my name and what's my name? And it gave me the same response. And this time the memory is being preserved into a database, right? No, nothing kind of in memory or nothing stored onto the process itself. Rather, these are persisted into the disk, right? So this is what I wanted to show you. Now, moving back to the slides. So now we briefly discussed about the AI agent memories. Let's also talk about the architecture or the React pattern that we discussed initially, right? Because this is very crucial when you are building up the agent, because you don't want your AI agent to always hallucinate or don't have that confidence. You always want your AI agent to be confident, or at least give you 90% or close to the real output or the expected output. And that is where the React patterns comes into picture, where there is a continuous loop that is running until you get a desired output. And this is how it flows. You intend to ask a question, it goes to the LLM, then it goes to the tools as well. LLM decides whether it needs to call a tool or a not, and then it continuously observes the answer. And if it matches, then the answer is spitted out to the end user. Otherwise, it will again go to the entire again loop where the response is where the LLM tries to improve onto that response by executing the tools again, or see if it can do something better. Now, few production consideration when you are building up AI agents. That one we saw today, this was just a demo or a workshop meant for workshop purpose. But if you're building it for production systems, always ensure that the error handlings are there. You have always defined the rate limiting at your AI agent level, because we know that there are rate limiting enforced at the model level. The AI models that you are using, you will always run out of the quotas. So always ensure that you have the rate limiting enabled at your AI agent, so that you don't hit those quotas. Always ensure that security is the first principle. You can always ensure that your AI agents are secure enough. They're not doing what they are, not supposed to do. Always have logging and proper observability. If you're using LangChain ecosystem, you can consider exploring Langsmith, or there are other open source tools as well for which you can use those for having the observability and logging onto your AI agents. You can always have, or you should always have the memory with your AI agents, because AI agent without a memory, it doesn't make sense. It's of no use, because if it is not able to preserve the older context, if you have to always start fresh, then you will lose the productivity, or you will lose the intent for which the agent is supposed to work for you. The meaning will go away. And if you want to scale out, you can also consider having vector DBs, where you can build your knowledge base on the top of vector DB, and you can integrate your AI agents with those vector DBs built against the RAG systems, so that your your LLM can directly call to those vector DB and get you the responses from that memory as well. So this is what I had for today. I have also mentioned my LinkedIn details. Feel free to reach out to me. And if there are any questions, I'm happy to take them down.